Hello, this is Patrice Ferlet. At first, yes, I know my English is very bad, so excuse my English, and if you don't understand what I want to say, just watch the screen. I guess you will understand this tutorial. So, what I want to do now is to present how open shading language could be used in Blender. This is based on a nice tutorial made in the Blender Diplomas website. This very useful tutorial helped me to understand how to create an absorption shader. Absorption is the way that a material absorbs the color of lights inside the volume. Oh, my cat is stealing something. Okay, so this is a very interesting tutorial, and but this tutorial uses some nodes, a big node chains. So the goal today is to use open shading language, which is implemented in Blender. This language is an open language used by a lot of renderer as renderman. Excuse me, I forget the name. Okay, so the open shading language is very useful. Is very nice language. You can check and read the open shading language specification, which is a PDF, but my advice is to read some documentation on internet, because sometimes the specification hasn't every function. So working with this tutorial, I created a shader that makes exactly the same. This tutorial used the Beer-Lambert Law. Beer-Lambert Law is a law of physics which explains how a light is absorbed by a volume using this simple calculation. E is the exponential function. So just to be clear, if you set e power of a value, this is as using exponential value. You will see this in my source code, so don't be afraid. Okay. This is very simple. We only have to set exponential of minus theta ln. N is the density, L is the ray length, and theta is a cross-section absorption. We only have to work with L and N because the incidence there, the cross-section, will be calculated by open shading language with the N global value. So just go to the Blender interface and remove the cube and the lamp and add Susan. This is the monkey. Okay, so now you can just set up your scene, just move the monkey like that, add a plane, scale up, create a wall by extruding the back face like that. Okay, we will scale it or larger, and append a modifier subdivision surface with 2 subdivision, smooth, and do the same for the monkey. Modifier subdivision surface to subdivision and smooth. Okay, we know add another plane which will be used to create a lamp light. We'll scale it up like that. Okay, so now you can use the cycles render and go to the compositing interface. You can change the compositing interface, the interface, by pressing Ctrl and left or right arrow, like that. Okay, so I set this view to 3D view, and I will set this viewport to the rendered. We haven't set our plane to be an emission shader, so I just set it now. Emission, and set it to maybe 8. Oh, 5. 5 is good. Okay, so now we will create our shader. So you can split area and use text editor there and give a name to your text. So I set it to node absorption.osl. Give OSL extension. This is very important because we will use the syntax elite, and you can press the number, because if you have some error, this is the console terminal there, which will show you some error. So now can create a shader for the monkey. So I add this. As you can see, for now this is a simple diffuse color which is set to the monkey, but we want to create our shader. So you can now type there the shader code. So I will set a little comment to remember that E minus theta multiply lens. This is the red lens, like that. This is exactly what we want. Okay, so if you followed this tutorial, you have to know that we have to know if the light is inside, if the ray is inside the volume. So we have to use the back facing function. Back facing function will give -1 if we are not in the volume, and 1 if we are in back facing in volume. So this is only what we have to know. Okay, so create the shader. To create a shader this is like create a function in C++, but instead of using function keyword, we will use shader keyword. We can now give a name to the shader. So absorption, well, my absorption, and as in C++ for the function, we have input there and the body of the function there. But using shader, you have to set input there and output exactly as like this tutorial. We will mix two colors. So we will use the mix function. We'll use color 1, color 2, and a coefficient there. Okay, so we need two color the first color is the inside color. So set a color named name inside color, give a default value, so color 0800, another color outside color 0.8, it's okay, and we need the theta. We'll name it fac for factor, and this is a floating value, so float fac and set it to 1 by default. Okay, so what we need to do is to mix inside, pressing Control space, this is auto completed, and outside color by a factor. This is not the factor we have in input, but the absorption color, the absorption coefficient, absorbed. Okay, so the absorbed should be a value, a floating value, which is 1 by default. Okay, so now we can calculate absorption. Absorption is exponential of minus fac multiply radians, but we don't have this value. This value can be taken from Blender using the get attribute function. Get attribute function use the first argument is a string, which is this, and the second argument is the variable you want to set. I found this inside the OSL language specification to check where is get attribute. I will just show you get attribute. There, get attribute use string name, output the destination. So you should set a float ray length, and we will get attribute. So this is path ray length, comma ray length. Okay, so get attribute will get the path ray length and set it to the ray length variable. Okay, so now we have another thing to do. This is to multiply by the back facing function to be sure that the absorption is only calculated when we are inside the volume. Back facing. Back facing is a function which is not in documentation. I don't know why, but okay. So now this mix color should be declared. This is the shade color, and the shade will be returned. So I need to set an output. To set an output, just begin your attributes, your parameters with output, and set the type and a name. We will set the name out, and set it to a color as black by default. Okay, so the out color, out is now the mix of absorption and of inside color and outside color given by the absorption parameter, absorption coefficient, we just calculate it there. Okay, so to use this I will add my shader like that. So if you didn't see input and output, that means you have an error inside the code, and the error could be checked inside the console. So I see this line as an error, and get attribute relance. Okay, I just mistake. Another error. OSL screw compilation error syntax. There path. Yes. Excuse me. This is a double quote. Okay. Okay. So as you can see, we've got our two color in input, inside color, outside color. This is our color there. The FAC there. This is the FAC input, and an output, which is a yellow point because this is a simple color. So the color in output is there, and this is the mix. Okay, so I cannot link out to surface because the color is not a closure. I will explain what is it, but at this time I just use my shader like that. I use, for example, a transparent shader. I set the output to the color input and the BSDF in surface, but at this time this is not very this is not working because we forget to check something in the render tab. We want to use the open shading language there. If you don't check this, your shader will be not used. So click on, and this is okay. So what we can see now is that we've got what we want. Not exactly, but I can change the value, the fact value, and as you can see, this change the way array is absorbed inside this volume. This is somehow black there, so just change the color to be more visible. Okay, so the inside color can be green, the outside is a blue, a very light blue, and as you can see now, absorption works. So just save this because sometimes Blender can crash with OSL, so I prefer to save sometimes. Okay, so if you want to change this the transparency, you can set it to the glass, and as you can see now, this is very nice. That two in your okay. So you can see there is a difference between our script and the glass. The output is green there. Our output is yellow. As I said, our color out is a simple color, but there this is a glass, and the glass has a green point because this is a closure. A closure in open shading language is in fact a function. This is a virtual value which will be calculated when the shader is used in one ray. So we need to change our shader to have a green point there, and we can add this glass behavior inside our shader. So how to do? This is very simple. Just disconnect the glass shader and we will change this. In fact, I just want to show you something. The glass shader need your factor. This is the refraction factor we will need inside the volume. So I will add an input. This is the your, like that, and now you can remove this and we will use the your. To use the your inside the refraction shader, you can just check inside the language specification and you can see that we have refraction there. The refraction is a function which is declared inside OpenShading language. So the refraction uses normal n and a float. This is the your there. N is a global value which is described there, and n is the surface shading normal of the surface at P. P is the point you are shading. So to use the refraction there, you can set now you can use the refraction function with n and the your value you give to your shader, and to set the output not only a simple color, you should use the keyword closure. Okay, I just want to say this. So now the output is not a simple color. This is a shader color. This is a closure, and we have to multiply our color with the refraction and comma your. So now the mix color, the simple color, is multiplied with refraction there. So if I there is no there, can I send color to code? The closure cannot be declared, cannot be initialized with a simple color, so I just set it to I don't remember the name, Hangout, something. Old out, yes, old out is a simple closure color that doesn't represent something. So old out, yes. So now, as you can see, the output is a green point. We have the your value, the fact value is there, and you can now link your shader to the material output. So setting the your to 1.2 and the your is okay. So this means that you can set the your inside the volume. And now you can set a more realistic material using other shader. For example, you can set a glossy shader, add mix shader, like that. Set this one like that, link that, and the surface there. And we want to set it, this will crash. It crashed. Okay, so we can I redo the same refraction and your hold out. Okay, and just Okay, so excuse me, sometimes it crashes and don't know why. So okay, this is the glossy, and I mix the shader like that, there. Okay, and rendered. Okay, and set it to 0.1, for example. It's okay. So you can see now that we have a reflection and a reflection. Set the rawness to 0 and the UR to 1.3, for example. It's okay, and the fact of the mix can be the Fresnel input. Okay, so set it like that, and this is very, very nice. Okay, so I set the camera there. Okay, and just to show you, I will change the sampling to launch a render. Okay, so now I can press like that, and as you can see, there is a lot of samples now, but the light is absorbed by our volume exactly as we described this in the shader. So open shading language is a very nice language. This is not very, very easy, but by training and reading some documentation, you will be able to create some very, very, very impressive shader only with a sample of line of code. So I think this is the end of the tutorial, so thank you for watching, and if you have any question I can answer by mail. Send a message on the YouTube channel or on my personal mail on YouTube, and I can I will be able to answer. I think I write English better than I speak English, so one more time excuse my English, and thank you for watching.